I'm Jake O'Neal, creator of Animagraphs, and this is how a World War II submarine works. We've built a generalized teaching model from the era. For those interested, our source inspiration comes from Gato and Balao class boats. The submarine consists of a reinforced tube called the pressure hull, running the length of the ship, which houses all personnel and sensitive machinery. This inner hull is divided into 8 individually watertight compartments, which are separated by reinforced structural barriers called bulkheads. Special pressure-rated doors separate and isolate these bulkheads, which we'll examine later. An additional watertight cylinder above the hull forms the conning tower. Wrapped around this core, there's an outer hull which houses tanks for fuel, ballast water, air, and other essential liquids and gases. A hollow superstructure extends along the top of the boat from the main deck, with limber holes so water can flood or drain as needed. Now, let's get into the details, starting at the front or bow of the ship. There's a large buoyancy tank that's part of the diving system. Shutters on both sides cover 6 forward torpedo tubes. The anchor is perched here, connected by 600 feet of chain. The anchor can free fall when released. A motorized device called a Wildcat hauls the chain back up, storing it in a special chain locker near the bow. The bow planes are also nearby. A hydraulic ram drives a shaft to tilt the planes, allowing the submarine to, in a way, fly through the water when submerged. The planes fold up while surfaced, since they're no longer needed, and to protect them from rough seas. From here, we can see the forward torpedo room. There are 16 torpedoes here, with 6 in the tubes ready to fire, and 10 reloads stored in the compartment. They're 20 plus feet long and 21 inches in diameter, weighing about 3,000 pounds each. Between the tubes, there's the gyro angle setter, which continuously updates the angle setting inside the torpedoes for firing at a different angle or course than the submarine itself, resulting in a curved shot. These analog computers are one of many such devices on board, which we'll examine in more detail as we encounter them. The torpedoes themselves are expensive, technically advanced machines. The gyro angle setting from the computer is translated through a rotating shaft on the tube to set the torpedo's inner gyro. Rods extend from the gyro rearward to rudders. Every torpedo has its own adjusted setting based on its location in the submarine. Torpedo depth and speed are set by hand from controls on the side of the tube. The gyro angle can also be set by hand if needed. There are 6 movable bunks suspended from the ceiling, but this compartment could accommodate up to 15 beds. There's a crew's head or toilet here, and a shower that's mostly used by officers. A hatch overhead provides access to the escape trunk, which in turn leads to the bridge. The escape trunk can be individually sealed and either flooded or drained. Flooding may be necessary to equalize inside and outside pressure for safe human passage in adverse conditions. The underwater log is attached to the port side hull. with a rod that extends 3 feet beyond the outer hole. The rod has openings at the tip through which seawater flows to measure pressure differences, and thereby derive speed and distance traveled. Heading aft or rearward, we pass through a bulkhead with its watertight door. We've now moved into officers' quarters. There's a small pantry here for serving food to officers, though only coffee and toast are actually prepared here, with food itself coming from the crew's galley. The adjacent officers' wardroom serves as a mess hall, recreation room, workspace, and meeting room. There are 4 bunks at the other side, with an additional 6 bunks down the hall. The rooms are partitioned with textile curtains. The captain's room is separate from the rest, with redundant course indicator and depth gauges mounted on the wall. A writing desk, and wall-mounted components for access to the ship's communication systems. There would be anywhere from 6 to 8 officers on board. There's a small office at the end of the hall with a typewriter for record keeping. From officer country, we pass through another bulkhead into the control room, which is packed to the last square inch with state-of-the-art technology for its time. At the center, there's a dead reckoning tracer, which takes input from the previously shown underwater log device and the nearby master compass to automatically move a pencil, which draws the ship's course on a map or chart underneath. It has knobs to make adjustments or recalibrate the device when maps are swapped out. The master gyro compass occupies a large case underneath a central table with a shatterproof glass viewing port. It uses gyroscopic forces to find true north instead of magnetic north. Magnetic compass accuracy can be negatively affected by other electrical or metal objects, including the ship's hull. At the heart of the gyro compass, a spinning element sits suspended in a cup partially filled with mercury. This element's rotation is electrically driven. The cup is part of a hollow metal sphere that is itself suspended in mercury, encased by an outer supporting sphere. The core apparatus is held and isolated from shocks by a ring of soft springs and flexible metal bumpers with felt tips, which extend from an inner gimbal ring. Through connection to an outer gimbal ring, the compass maintains its own specific orientation, apart from the submarine's movement. The highly sensitive spinning core maintains its relationship to Earth's gravity, allowing finite directional changes to be continuously tracked. Above this central table, there's a bathythermograph that charts water temperature at various depths on paper cards. Water temperature affects, among other things, sonar range and accuracy, including avoiding sonar detection from other vessels. There's a fathometer, which displays the result of pings to determine the depth of water below the keel. There are repeating gauges for target bearing and range. Along the port side wall, which would be the left side of the submarine looking towards the front, there's the diving station, with separate wheels to control the previously shown bow plane angle, and a similar plane at the stern. Each wheel has its own water depth to keel gauge, plane angle indicator, an inclinometer that works something like a construction level using an air bubble in a liquid to track boat angle, with separate glass tubes for coarse and fine readings. In the center, there's a deep depth gauge. and a barometer to measure internal air pressure. Moving forward on this side, there's the hull opening indicator panel, with status lights which show red for open or green for closed, corresponding to the many vents, exhaust ports, hatches, and so on through which seawater may enter. The boat is ready to dive when all lights are green. Even then, some air is pumped into the boat, and the barometer gauge is checked to verify increased internal pressure, ensuring water tightness. Below that, the main hydraulic controls, which control vents, valves, and many other crucial hydraulic systems. At the back of this side, there's the trim manifold, which is used to pump water from and to the sea, or between tanks. On the opposite or starboard side of the control room, starting from the rear, we see the air manifolds and gauges. This station manages air throughout the boat. Air is used in ballast tanks, for firing torpedoes, to run many gauges and instruments on board, for ventilation and breathing, and so on. In front of that, there's the gyro compass control panel, with metal twist knobs, indicator lights, and gauges to oversee gyro compass function, and relay readings to various repeating gauges at other locations aboard the vessel. Next to that, there's a large switchboard to monitor and configure the many electrical systems on board, and also indicate the status of machinery to other parts of the ship. At the front of the control room, there's an auxiliary steering station. The boat's main steering wheel is in the conning tower. An auxiliary gyro compass sits behind this wheel. There are repeater gauges for the underwater log, compass, rudder angle, and motor order telegraph, which is used to send motor orders to other parts of the ship. There's a ladder here which leads to a hatch on the main deck. At the back of the control room, we see two large periscope well tubes that pass completely through the control room, with various equipment control boxes attached. Near the ceiling, there are 3 colored alarms. Green is the diving alarm, whose alert meant sailors had 10 seconds to get below decks, secure hatches, and begin the dive. The yellow alarm is for general quarters, meaning sailors would race to battle stations and prepare for combat. The red is the collision alarm. When this alarm sounded, sailors closed all watertight doors, among other protocols. There's a ladder here which takes us into the conning tower. The conning tower gets its name from the root word con, meaning to conduct or steer. This is the main attack and navigation center for the ship. At the center, there are 2 periscopes. Let's zoom out and get the full view. Periscopes extend upwards through periscope shears, which are visible at the exterior when the boat is surfaced. Max effective periscope depth is 65 feet, which the submarine can reach in an incredible 35 seconds. Wells extend from the shears all the way to the bottom of the pressure hull, with rubber bump stops at the end of their travel. The forward scope is the observation or search periscope. It's shorter but thicker in circumference, making it easier for the enemy to see. It has superior capabilities in low light conditions. Below the main viewport, there's a radar installation. The rear scope is the attack periscope. Its much thinner profile makes it harder to spot. It's also about 4 feet longer, allowing deeper dive depth. Back in the conning tower, handles are unfolded to rotate the periscope. Handles also twist to control other available periscope features. The attack scope has an optical rangefinder to determine distance to target, with a supporting statometer, which helps derive target distance by comparing viewing angles top to bottom for objects with a known height. Turning towards the starboard or right side of the ship looking forward, there's an inclinometer. There's also indicator gauges and controls for various types of onboard radar. In front of that, there's the sonar control panel with gauges and knobs to remotely direct various sonar projectors. Visible sonar components include a rotating hydrophone at the starboard side of the bridge for standard sonar capability, and 2 retractable sonar projectors under the hull near the front of the boat for supersonic sounds. That is, sound that humans can't hear without the aid of equipment. Back in the conning tower, there's a ladder which leads outside to the lookout platform above. The main steering station is at the forward wall, with the ship's main steering wheel, and familiar gauges for speed and distance traveled, rudder angle, compass repeater, and a motor order telegraph. Moving to the port side wall, we see the torpedo firing panel, with status indicator lights and firing switches for each tube. Behind that, the torpedo data computer. This is an analog computer weighing in at about 1,500 pounds. Instead of circuit boards and chips, it uses electrically driven physical gears, wheels, levers, and so on to make complex trigonometry calculations for accurate torpedo firing between the constantly moving submarine and targets, at ranges up to 9,000 yards, and angled shots up to 90 degrees right or left. Calculation results are sent to other systems on board. Against the back wall, there's a dead reckoning tracer like the one found in the control room. Let's head back down the ladder. At the rear of the control room, there's a separate radio room which is filled with communication equipment. Near the door, there's a special cipher machine for receiving and transmitting coded messages. Traveling aft or rearward through another pressure bulkhead, we enter the main crew areas, where the ship's 60 to 70 crew members eat, sleep, and congregate during off-duty hours. All the food for the crew and officers is prepared in this small galley. A large, distinctive coffee urn or percolator is at the open end of the galley for easy access to crew. There's a floor hatch for food storage in the hold. The mess area has various tables with benches that double as storage chests. Apart from meals, the crew could relax here, listen to the radio, or play board or card games. There's a bookcase at one end, and a drinking fountain over the sink, among various food storage and preparation compartments. A ladder near the back leads out to the main deck. Passing through the curtain at the end of the mess room leads us into the crew's quarters. There are 36 bunks for sleeping, with individual storage bags suspended from the bunk rails. Bunks were used in a shared rotation between crew members, with some sleeping while others were on duty. There's a dedicated ice cream storage freezer at the starboard side. Dangerous and stressful conditions aboard submarines meant these sailors were afforded the best food in the Navy to keep up morale. At the back, there are 2 restrooms, 2 showers, and a washing machine. We continue rearward, heading through a pressure door into the engine room. 4 huge diesel engines provide power for the submarine. A few different types were common for the era. I've chosen to feature the 10-cylinder opposed piston model. Each engine is individually rated for 1,600 horsepower. The engines extend between decks from the bottom to the top of the pressure hull at the sides. They rotate opposite one another for balance. All are supercharged. The air intake has an attached silencer to mitigate noise, which would otherwise be deafening. Even so, the running engines were so loud that operators used hand signals for communication. Air intake caused a strong breeze through the engine room. Air arrives at the engine room from the main air induction valve, just aft of the conning tower. Its high position helped prevent flooding when surfaced. Engines are cooled with both a closed freshwater and an open seawater system. Seawater is sprayed into mufflers to act as a spark arrestor. The engines exhaust out through side ports beneath the bridge superstructure. There's an additional, smaller 7-cylinder auxiliary engine at the bottom of the pressure hole. There's a ladder at the back of the engine room for access to the main deck. There are 3 special fuel ballast tanks with vents, water flood valves, and air blowers that can be used as part of the main ballast system. Water, fuel, air, or a combination of any of these can be distributed to these tanks as needed. These are supplemented by 4 normal fuel tanks with valves for compensating seawater to enter, so the ship can maintain enough weight to submerge. Salt water is heavier than the submarine's fuel, so seawater is pumped into the tank but settles to the bottom as fuel is consumed. Heading further aft, we enter the motor room. The submarine uses a diesel-electric setup, where each diesel engine has an attached electrical generator. Power from these generators runs 4 electric motors. When submerged, the diesel engines are shut off, and power from the motors comes from battery banks that take up a large portion of the submarine's lower deck or hold area. There are forward and aft battery compartments, with 126 battery cells in each compartment. A single battery is about the size of an outdoor trash can. These compartments have complex air and water systems for both ventilation and cooling. When surfaced, some of the generator's power is used to charge the batteries. Now let's return to the motor room. The ship has 4 electrical motors that operate best at high speeds. Motor shafts pass through a reduction gear since the propellers operate best at moderate to slower speeds. Noise from this reduction gear was the loudest sound produced underwater, so much effort went into designing quieter gear assemblies. From the reduction gear, 2 main propeller shafts extend outside the ship on each side. Max speeds on the surface using all available propulsion sources is 21 knots, while max submerged speed under battery power is 9 knots. At max underwater speeds, the batteries only lasted about 30 minutes. Maximum underwater range is around 100 miles at 3 knots. In practice, most dives were short, and any dive over 16 to 18 hours was considered dangerous. Located just above the motor room, the maneuvering room is the control center for this complex power plant and propulsion system. The stand and its various levers control, for example, electrical motor speed and rotation direction. They can remotely control the diesel engines. There are gauges for propeller shaft speed, motor order telegraph repeater gauges, and many smaller gauges to track the complex electrical circuitry throughout. The system is highly flexible for many combinations of both diesel engine and battery power for powering onboard systems and the propeller shafts. There's also a fully functional metalworking lathe at the starboard side. The cubicle in the center is packed with components that link gauges and levers to their functional counterparts. There's a small engineer's office at the back of the room. From here, we pass through the final pressure door into the Aft Torpedo Room. There are 8 torpedoes here, 4 in the tubes, and 4 reloads on skids just behind. I've shown 6 bunks, though up to 15 could be deployed in this room. There's another head here as well. As for the inside of the boat, the only remaining compartment we haven't seen is the pump room, which is beneath the control room. It houses various air, water, and hydraulic pumps. Behind that, and beneath the crew's galley and mess, is a storage space for food and ammunition. Submarines had various gun configurations. Our model features 2 40mm guns fore and aft of the conning tower with a shorter range, and 1 gun at the front for longer range targets. There are watertight, pressure-proof canisters mounted nearby with ammunition and replacement gun barrels. All of these guns were used for anti-aircraft and some surface targets. The main deck has teakwood planks at the center, painted black like the rest of the deck to camouflage. She could be completely invisible to human eyes from overhead craft when submerged. The raised portion at the center is the fairwater or sail, which wraps around the conning tower cylinder. There are 2 target-bearing transmitters, which are optical devices to track enemy targets. There's a button to mark the bearing or angle of the target relative to the submarine, and automatically send this information to the torpedo data computer for use throughout the system. There's a searchlight and radar masts. Air. Air is used in many critical submarine functions and tasks. There are canisters that supply pressurized air to eject torpedoes from tubes. Other tanks supply air for expelling water from ballast tanks to resurface, also called blowing the tanks. There's air supply for many components on board, and air for breathing when necessary. The ship had about 15 hours of breathable oxygen at dive time. Fresh air could be added from stores but would increase internal boat pressure, releasing emissions of any kind, including air bubbles, might be dangerous in close quarters with enemy craft. Diving. To dive, all engine and ventilation intake and exhaust ports are closed. Ballast tank vents are opened to allow air to escape and water to enter, inducing a state of negative buoyancy. The bow planes are rotated to guide the ship into a dive, driven by the ship's forward movement. Rotating stern planes adjust the dive angle. Once the desired depth is reached, some air is pumped back into ballast tanks to achieve neutral buoyancy. Water is also moved between tanks for a balanced trim, meaning the angle of the boat should be level without excessive help from the planes. At depth, bow planes are now used to alter the ship's depth. Doors. Individual watertight compartments can serve to isolate damaged areas of the hull, so the ship can remain afloat even if one section is flooded. As such, special doors are designed to withstand high-pressure conditions. They're installed into the reinforced bulkheads. There are sturdy rotating levers at the edges of the door called dogs. With a couple turns of a central handle, a worm gear actuates parts connected to individual dogs. Rotating these levers into place. The inherent leverage in the system makes for a tight seal. as the rubber door gasket presses against an exposed metal part of the door frame called the knife edge. These submarines are seagoing works of art, and even with the detail I've shown, there's so much more to them than I could cover here. I'm in awe of the skilled folks who built these machines.